Okay, let's illustrate the binomial distribution using the example shown here on slide 20. We are told that according to the CRTC, 80% of Canadian households have access to high-speed internet, and we are told that we're going to pick 20 of these households at random, excuse me, and we're asked a series of questions about the probability. All right, now, how do I know this is a binomial distribution? Well, for one thing, we are picking at random 20 households from a large population. So my sample size 20 is very small in relation to my total population size. I am given an n value, which is my sample size of 20, and I'm given a proportion, the p, that's listed in the formula. And that P is the proportion of the population with the characteristic of interest. And in our case, we're talking about Canadian households that have access to high-speed internet, and that percentage is 80%, which I could express as a proportion, and that's going to be 0.8. So P is equal to 0.8, N is equal to 20. The other thing that makes this a binomial is the fact that we are counting. So we pick 20 households, presumably whoever's conducting this survey phones up these households and asks them whether or not they have access to high-speed internet. And when we do this, we're counting out of those 20 how many have access. And because we're counting, that's a whole number. We're not actually measuring anything, we're counting. All right, so let's have a look at each of these questions in turn. The first one is asking me, what is the probability that exactly 15 of these 20 households have access to high-speed internet? All right, I'm going to go to the next slide and we're going to see how this is worked out. All right, so first of all, what I am told, what I know about this situation is that it is a binomial. My sample size is equal to 20, so n is equal to 20, and the proportion of my population with the characteristic of interest is 0.8. Yes, I know this looks messy, but it's the best I can do. Okay, so I know these two values. These are known as the parameters of the binomial distribution, and these are the only values really that I need to know, other than the fact that I need to know what the x is. So the first question asked me, what's the probability that 15 of these 20 households have access to high-speed internet? So x is equal to 15. The formula a few slides back is given right here on how we calculate that probability. And I simply plug in the values. So n is equal to 20, so it's 20 factorial divided by x factorial, which is 15 factorial in this case, times n minus x. So that's 20 minus 5, or sorry, 20 minus 15 gives me 5 factorial. P is equal to 0.8, that's raised to the power of x, which in my case is 15, times 1 minus p, so 1 minus 0.8 is going to get me 0.2, raised to the power of 20 minus 15, which gets me 5. Now I can plug all this in my calculator, and I'm going to get an answer of 0.174560. Okay, that's great, but hey, let's face it, we're all lazy. And Minitab can give us our answer as well. So I'm going to open up Minitab here for a second. Bear with me for 1 minute. Okay, so I've got Minitab open here, and in order to do calculations involving the binomial, we go to the Calc tab. Second from the bottom says probability distributions. There are a pretty extensive list here, but the one we're interested at the moment in is the binomial. So I choose that, and the window opens up, and I have to input a few things here. Now, the number of trials is my sample size. We have picked 20 Canadian households at random, and we know that 80% of Canadian households have access to high-speed internet, so that goes in as my event probability. Now, I need to change my radio buttons up here. To answer question A, I want straightforward probability. This is what I call equal to probability. And I'm going to change my radio button down here. I can input a single number, which is what I'm going to do here. So I want to know what's the probability x is equal to 15 when n is 20 and p is equal to 0.8. Click OK, and here's my answer. And this is the answer that is showing in your notes. Now, a couple of things to note about this display. First of all, Minitab prints this out and says this is probability density function. And what that means is that the answer that we have is the probability that x is precisely equal to a particular value. Note this symbol right here says equal to. So when small x is equal to 15, the probability that large x is equal to small x, so probability x is equal to 15, will be equal to the 0.17456.